Alright guys, so we checked out some basic inverses and finding basic inverses of linear functions, so we want to move on to a little bit more difficult functions here. We're dealing with quadratics and finding the inverse of a quadratic function. So here f of x is equal to x squared minus 9. We want to find the inverse function, or f inverse of x. The process is the same, it's just a little bit different when it works out in the end. So let's check this out. So let's go through this process. We're going to switch the x's and the y's. So here I'm going to have x equals y squared minus 9. And this is no different from what we did before. We want to isolate y, so we add 9 to both sides. And then the next thing is I need to undo what's being done to y. Y is being raised to the second power. In order to do that, I take the square root. Whatever I do on one side, I got to do on the other. And we know that anytime you take a square root, we have to end up with a positive version and a negative version of that particular argument. So plus and minus the square root of x plus 9, and this is really what's different. That's equal to y, or in other words, f inverse of x. The last thing that we'll mention is we know that there are some numbers that we can't plug into this function. Particularly, we know that if we get a negative under the square root, we're not going to get a real number for an answer. So what we have to do is we've got to have x plus 9, we've got to have that be bigger than or equal to 0. And if it's not, we know that we don't get real number answers. So what has to happen is we've got to kind of mention this fact that we've got this inverse, but it's not a function because essentially what happens is we have two different versions when we plug in a number for x, and also we've got restrictions on the domain for this inverse function. And particularly anything that we plug in, if we want a real number answer, anything that we plug in has to be greater than or equal to 9. So the process in finding the inverse is the same. It just gets a little bit more complicated as far as domain restrictions. So this is a domain restriction. And to put that simply again, that just means that there are certain numbers that we can't plug in if we want a real number answered out of this inverse function. And then the other thing is we always get a plus or minus. We always get two versions when we're dealing with quadratics because we have to take the square root in order to undo what's being done to it. Okay, so to answer this, our inverse, the inverse of f of x, this is our answer here. It's equal to plus or minus the square root of x plus 9. That's the inverse function. But the little things about this function are the domain restrictions, and we always get two different answers, which makes it actually not a function. Let's check out another example of this. We're finding the inverse here of f of x if f of x equals x squared minus 8. So let's go through again. We're going to switch the x's and the y's. So I'm going to have x equals y squared minus 8. We're going to go through that same process that's outlined before, or outlined up here from when we did linear functions, inverses of linear functions. So we're going to add 8 to both sides. We get x plus 8 equals y squared. And we take the square root of that, and we know we always get a plus or minus when we take the square root. So that's going to be equal to the inverse of f of x, and that's our function. So again, you can see here we're just going to mention these things. Number one, we've got a variable under the square root, so we've got a domain restriction that we should make note of. The domain restriction is we know whatever's under that square root, in other words x plus 8, that's the argument under the square root, that's got to be bigger than or equal to 0 if we want real number answers. So x has to be greater than or equal to negative 8. And then the other thing is we get two answers when we plug in a particular value for x. And that essentially means that this is not a function. So this is the inverse of f of x. It's got restrictions on what we can plug into it. and we get two answers when we find that inverse.